In this lesson, we are going to discuss the law of large numbers and expected value. Now, to discuss the law of large numbers, I want you to take into consideration flipping a coin. If I flip a coin one time, there is a 50% chance that I'm going to get a tail. If I flip the coin a second time and a third time, and all three times I get a tail, that's telling me that 100% of the time I'm getting tails in 3 trials. Where the theoretical probability is 50% that I would get a tail. Now, it's unlikely if I flip the coin 100 times and I still get all tails. The more trials I have, the more accurate that overall probability is going to be. So, in other words, if you toss a coin once, you can't predict exactly how it's going to land. You can only state the probability that you're going to get a tail is 50%. If you toss the coin 100 times, you still can't predict precisely how many eggs are going to occur, but you can reasonably expect to get close to 50% most of the time. If you were to toss the coin 1,000 times, you would expect the probability of eggs to be even closer to 50%. And in general, the more times you toss that coin, meaning the more trials you have, the closer the percentage of eggs or tails will be exactly to 50%. So the idea that large numbers of events may show some pattern while individual events are unpredictable. This is the idea of the law of large numbers. The more trials you have, the closer you're going to get to that theoretical probability. But if you look at an individual trial or a small group of individual trials, that may be way off from the theoretical probability. Now, expected value is what to expect in an experiment in the long run after many trials. What is that value that we would expect to have after many, many trials? And so to calculate expected value, what you would do is you would take the value of event 1 and you would multiply it by the probability of that event happening. Then you would add it, if you have a second event, you would add it to the value of event 2, and then multiply it by the probability of event 2. And you would just keep doing that for however many events that you have. You take the value of the event, multiply it by its corresponding probability, and then you add all those values up. Okay, so the first example I'm going to run through with you on this is about a lottery ticket. And the best way, in my opinion, to do this is to make a chart because it really organizes the information and makes it easier to follow the steps. So I'm going to write event for my first column, the value, and the probability. Okay, so in this example, we have a lottery ticket that's $1. You have a 1 in 5 chance to win a free ticket, which is worth $1. You have 1 in 100 chance to win $5, 1 in 100,000 to win $1,000, and 1 in 10 million to win $1 million. Discuss the implications and find the expected value. Okay, so we're going to list all the different events that happen. The first event is buying the ticket. The value of that ticket is $1. But to you, you're doing this from your perspective. You're losing that $1 because you're giving that away. And the probability of that happening is 100%, or in decimal form is 1, because you absolutely have to pay that dollar in order to participate in the lottery. So I would take -1 times 1, so I'll make this column the product. You take -1 times 1 and you get -1. The next event is if you could win a free ticket. If you win a free ticket, that value to you is a plus $1. You get that dollar. The probability of that happening, based on the information that's given to us in the problem, is a 1 in 5 chance. So I'm going to put 1 out of 5 here. And then I'm going to write down the product. If I take $1 times 1/5, that's going to give me 20 cents. Now, the chance to win $5. That's the next event. According to the information in the problem, you have a 1 in 100 chance to win $5. So the value to you would be a positive 5 because you're receiving that $5. The probability is 1 in 100. And the product, if I take $5 times 1 out of 100, that's going to give me 5 cents. The next event is if you win $1,000. According to the question, it says you have a 1 in 100,000 chance to win 1,000. So the value would be 1,000. The probability would be 1 in 100,000. And when I multiply those two and find the product, that would be 1 cent. Okay, last event, if you win $1 million. So if I win $1 million, the value to me would be $1 million, which would be awesome. And then the probability of getting $1 million is 1 in 10 million. So there's my probability, and when I multiply 1 million times 1 in 10 million, I get 10 cents. Now, the expected value would be what I get when I add all of these up. So on my calculator, I would put in -1 plus 0.20 for 20 cents, plus 0.05, plus 0.01, and plus 0.10. And when I add that up, I would get a -64 cents. So the expected value is -64, which means that's a 64-cent loss. So over many tickets, or averaged over many tickets, you should expect to lose 64 cents for every $1 lottery ticket that you purchase. So if you buy, say, 1,000 tickets, let me write this down, a loss for each $1 ticket. So if you buy 1,000 lottery tickets, that would be 1,000 times 64 cents loss, which would be $640. So you would expect to lose $640 if you purchase 1,000 lottery tickets. In the next example, it says an insurance policy sells for $1,000 based on past data. An average of 1 in 50 policyholders will file a $10,000 claim. An average of 1 in 100 policyholders will file a $25,000 claim. And an average of 1 in 250 policyholders will file a $60,000 claim. If the company sells 10,000 policies, what is the expected profit or loss? So what we need to do here is find the expected value first. So I'm going to make a chart like I did up in the previous example. Okay, and the first event is if someone purchases a policy. If they purchase a policy, that is going to be a profit to the company of $1,000. And the probability of that happening is going to be 1. In order for these events to take place, the person has to first, for sure, 100% buy a policy. And then I'm going to take that product, 1,000 times 1, and I'm going to write it down in this column. Okay, then the next event is if someone files a $10,000 claim. If someone files a $10,000 claim, that is a loss to the insurance company, so we're going to put that down as negative. And the chance of that happening is 1 in 50. So when I take and multiply 10,000 times 1 over 50, I'm going to get a loss of $200. Okay, next event is if someone makes a $25,000 claim. That would be a loss to the company of $25,000. And it says the probability of that happening is 1 in 100. So I'm going to take 25,000 and multiply it by 1 out of 100, and I'm going to get a loss of 250. Okay, the last event is if someone files a $60,000 claim, and there's a 1 in 250 chance that that happens. So that would be a loss to the company of $60,000, and that's a chance of 1 out of 250. So I'm going to take 60,000 and multiply by 1 over 250, and I'm going to get negative 240. Now, to find the expected value, I got to find the sum of all of these products. So I'm going to take 1,000, and I'm going to subtract 200, I'm going to subtract 250, and I'm going to subtract 240, and I'm going to get an expected value of positive $310. So what this means is, on average, for every 1,000 policy purchased, the company on average will make $310. That's a profit because it's in the positive. Now, the question always asks, what is the expected profit or loss if they sell 10,000 policies? So if for every policy I sell, the company is going to make $310, I'm going to take 10,000 times 310, and I'm going to get $3,100,000 on average when 10,000 policies are sold.